Hello everyone, this is Natas level 12 to level 13. We have a very similar looking web application as the previous exercise, except we have this extra line now that says for security reasons we now only accept image files. So they've got wise to our uploading a PHP script in the previous exercise. They've obviously added some more checks and conditions on the back end, and before we check the source code, the method of attack is still going to be the same. We found like an exploit here, and now it's a case of seeing if they've added enough security to really stop and prevent the attack. So we're going to do exactly the same thing, and we're going to try and work around any sort of obstacles we run into. So I'm going to make a PHP script the same as before. It's going to be the exact same script, just a PHP require, and I better use small quotes here, Natas web pass, Natas 14, like this, and put that into a script.php file. So now if I just check that that's what we want, and that is what we want, we just literally want to have a PHP script that contains the contents of this etc Natas 14 password file. So now we have our script set up. We're going to choose the file, and that's right here, and upload. And because we're doing the same attack as before, we're going to have to check and see if they've changed anything here, which there's still this .jpeg extension being added. So let's just change this to .php. That doesn't seem to be any different to before. And let's upload. Okay, so we hit this file is not an image response. So there is definitely some extra checks. Let's view the source, and let's remember this output here to see what we came into contact with there on the back end. So we've got the source code here, and I can see the sort of the same function declarations, and here's the sort of main body of the text. And scanning through, I can see that this is the sort of area we want to end up. This is the branch we want to hit in this condition, because at this point we get the file has been uploaded and a link where we can execute that, or where we can request that file. So that's what we would like to get. And we were given this file is not an image response. So we ran into problems when we hit this check here. And you can see that PHP is using this exif image type function. It's calling that with the sort of temp, seems like the temp name of the uploaded file. We could sort of we could double check this, but this I think we can safely assume is the file that we've uploaded. So it's running this function against our file, and it's obviously checking to see if it's an image. And I've opened up the PHP docs here with the exif image type function, as it's a PHP inbuilt function, and we can find out what it's doing. So you can see that it says exif image type reads the first bytes of an image and checks its signature. So it's looking at the actual bytes of the image, and it's using them to decide if the file is an image or not. So it's looking at the data itself. You know, it's not just looking at the extension to check. It's much more low level, it's much more fundamental, right? And as an attacker, we need to ask, well, is there any way to bypass this function? Can we somehow get our PHP script to look like an image at the bytes level? Which sounds like kind of almost like that wouldn't be possible. But there's this understanding of what a signature is here. So we can read this and maybe we're not sure how this function works, but we can look up file signatures. This kind of gives a hint towards this idea of something called a file signature. And I've also opened up a list of those on Wikipedia. I just Googled file signatures. You can even Google how to bypass the EXIF image type, and you're going to get a much more direct answer. But I think trying to sort of avoid really direct answers is maybe more useful. Like if we look at the sort of underlying um, understanding of what's happening, we can kind of create our own bypass, which is where we want to end up, right? We don't want to always have to rely on other people's um, findings, if possible, you know. But we have this list of file signatures, and if we read through the text, we can see that signatures are sometimes referred to as magic bytes or magic numbers. But to give you a sort of a real quick overview, it's the first sort of a few bytes of a file are often these particular magic bytes. They have nothing to do with the actual file data itself in terms of, say, an image, the actual pixel data that shows the image. But there's sort of some metadata, this first sort of section of the data that is used to identify what that file type is. And so if we sort of scroll down, we can look. I mean, here's JPEG, which is what we're looking for, but you could also say something like this Kodak Cineon image. So if you were to look at the actual bytes of a Kodak Cineon image file, you would see that the first 4 bytes are hex 82A, 5F, and D7. And that would be the same for all Kodak Cineon images. And so what this PHP EXIF image type function is doing is it's checking to see if the first few bytes of the file correspond to a image. I'm not sure what type of files it checks against, how many of these signatures, but we know it's using the signature, so it's going to be checking for these. And so for one sort of signature, it might check, is this FFD8 FFEE? So we need to ask ourselves, what happens if we were to add, or if we were to change the first few bytes of our PHP script to be these magic bytes? If we could somehow keep the script intact, but also have these magic bytes as the first few bytes of the file, then maybe the EXIF image type function would see those bytes and sort of mistakenly identify the file as an image. If that happened, then this would check out, and we would move to this um, else branch and successfully upload our PHP file. So that's what we need to try and do. That's the sort of what our idea of an attack is this time. We're going to append some magic bytes and see if we can bypass that function. So the question becomes now, how do we add those bytes? Like, how do we play around with this idea of a file signature? How do we view them? And how do we know that somehow this isn't going to break our PHP script? Well, we can add them in the shell or in terminal, and we can also view the bytes here as well. If you have a Unix-based operating system or the GNU core utils, you'll have this utility called XXD. I'm sure there's an equivalent in Windows if it's not present there. And we can pass a file to XXD, and it will print the hex representation of each of the bytes in that file. So we can see what the bytes look like in memory of this particular script, for instance. And on the right hand side, it shows us the sort of human readable, the printable representation of those bytes. And so it's using things like this that we can view, we can see the bytes, and we can also use just echo to add the magic bytes to the front of the file. I'm actually going to rewrite the entire script, but if we use echo, and then I'm going to use this FFD8FFEE file signature, purely because it's just small and quick to write in. If I write something like this \XFF, this is a escape sequence. And what that means is that when I submit this, this isn't going to be, we're not going to get \XFF written in the file. The operating system is going to see this \x and say, oh no, this needs to be the actual bytes FF. This needs to be the hexadecimal bytes FF here and not the printed characters \XFF. So escape sequences are, and mostly, if not all, I'm not entirely sure, these backslash followed by a letter or two letters, like a \T would correspond to a tab press. A \N is a new line, this kind of thing. And so we're going to use these escape sequences to add in the bytes. So it's DAFFEE. And then we're going to write our PHP script. Again, straight afterwards. Etsy, Natas web pass, Natas 14, semicolon, we need to make sure we have that, and then the double quotes. You have to be careful here because we have the double quotes on the outside of this string and then single quotes on the inside here for the Etsy file path. And then I'm going to overwrite our script.php by using this single arrow here. And so that should have appended the FFD8FFEE bytes to the beginning of the file. And if I run xxd again on our script.php, you can see the bytes are here, FFD8FFEE. And the bytes don't correspond to any printable character. So on the right hand side, they don't appear, they just appear as full stops or periods. To sort of represent that they're not printable characters. And so we've succeeded in adding the magic bytes to the beginning. Why does this PHP script, or why do we expect this PHP script will still work? Well, that's just because of the nature of PHP. PHP scans through the file looking for this opening PHP tag. And to sort of show this, we can look back at the source file. So we have like this opening PHP and this closing tag here. And PHP just cares about what's in between these tags. This is the PHP code, and this is what it's going to evaluate and process. Everything outside of those PHP tags is invisible, essentially, to PHP. It doesn't care about them. So in our code, these non-printable characters, these random bytes, don't mean anything to PHP. It's waiting to get to this opening PHP tag, and it's just convention not to close the PHP tags in a PHP script like this. If you were embedding it in HTML, you would close it. So in theory, this should be processed exactly the same as if these bytes weren't there. And so with that done, we're going to upload and see if our new script beats the security. So we're going to have to change this form to a PHP extension again. We're going to choose our file, which is our script.php, and there's no longer it doesn't show us the preview now that there's some unreadable characters in there. So we have our new script with the magic bytes set to this JPEG file signature. We've changed it to PHP here because we know we needed to do that already. And so we're hoping, yeah, that when we pass through that file, that our idea worked. You know, we sort of, from reading the docs, thought, okay, let's try and change, or let's try and add some magic bytes. And so what's happened in the source is that exif image type function has seen those bytes and said, oh yeah, this is a JPEG image. So, you know, we've got past that security check. And so now we should be able to hopefully click this if there's no other problems to overcome. And yeah, there's those 4 unprintable characters. And then this is the result of the rest of the PHP script. So this is the password for Natas 14. So I hope that was useful. I think that's quite interesting, these magic bytes and getting to play around with things at the bytes level. It feels very hackerish. So yeah, I hope that was enjoyable, and she'll see you in the next one.